Hi guys, today we'll talk about integral calculus. Alright, I did the last video about differential calculus, and this is going to be about integral calculus. Calculus, as I have already mentioned, is composed of integration, that comes from integral calculus, and differentiation, that comes from differential calculus. And they actually complement each other, and basically they're the opposites of each other, but the mathematical form of representing them may not imply that they are actual opposites of each other, but in theory they do. Alright, so as we know, if fx is a function, say equal to y, then the derivative of y with respect to x can be written as f dash of x or f prime x, and this is the general notation of writing a derivative. Alright, so if suppose we go back, say we go from f prime x to fx, we know the reverse process was differentiation that we had already done, and this process would be integration. Alright, now the way we represent this is that integral of f prime x with respect to dx is equal to fx. Alright, this is the integration sign, and this is the same thing as a sigma. Alright, this is the same thing as a sigma, but we add up really small elements. In sigma we can add up like 2 plus 2 plus 2 or something like that. Here we add up really small things, but we add them infinite times, so we end up with a finite value. Alright, now last time we did a derivative, found out a derivative, and that was of y is equal to x square. So the derivative of that would be equal to 2x. Therefore, the integral of 2x with respect to dx should be equal to y. This implies that the integral of x dx is equal to x square, or integral of this is equal to x square over 2. And this is how we come up with general integrals of certain functions. Alright, so this was the general notation. Now I'll discuss something really briefly, that is the actual meaning of integration. Integration, the word stands for integrating. That would mean that we are simply adding up, and as I already said, it's the same as summing it up by using this symbol. This is sigma. And how do we do that? Is basically we take up small areas or small strips from a function and we add them up. The areas add up to give a definite area of the function from one value to the other value of x. Now suppose we take the function f prime of x. Alright, say this is the function, and when I say what is the integral of f prime of x with respect to dx evaluated over the range from a to b, I actually get the area of the region A, and the region A is this area. So you see, even if this is not a simple polygon, in fact it is a curved region. So using geometry, it would be difficult for us to calculate its area very precisely. But integral calculus helps us with this purpose, and even if this curve would vary, like something like this over the range, we could still calculate the area of this region only by using this integration. But for that we really need to know what the integral of this function would be. Now another thing I would want to say is differentiation or finding out derivatives actually is done by the formula, and we have already discussed what the formula is. That is, derivative of y with respect to x would be equal to y evaluated at x naught plus delta x minus y evaluated at x naught divided by delta x limit delta x tends to 0, and this is the derivative evaluated at x naught. Alright, so this is the formula for finding out the derivative. Now if I have a function y, I can do this, that is, I can find this difference, divide it over delta x, and I can get the derivative. However, there is no formula for finding integrals of functions that we haven't encountered before. That is, if I give you a very vague and abstract function which has to make sense, well, that is a prerequisite, but I would have to know its the derivative of some function would give us that function, and only then I'm actually stating this backwards, but for that I need to know the answer beforehand. So that is one thing I want to say, that differentiation comes up with a formula, but integration is just the reverse process. We really do not have any formula for this. We need to know this. That is, if anyone asks me what is the integral of f dash x dx, I would have to know fx in advance, because when I do calculate the derivative of fx, I get f dash x, so, or f prime x. So the integral of f prime x with respect to dx would be fx. I need to know it in reverse order, whereas for differentiation there is only one way, that is using the formula. Alright, thank you.